Hi, I'm Willie. This video is about a framework called dalahast. It's designed for Haas with UI based on web. If you are not familiar with Haas, this is a link below, so you can check it out first. Now I'm going to go through the abstraction layer of dalahast. Dalahast try to solve some problems when people using Haas. If you use Haas as a topology system, you will find out it's hard to understand. The topology is pretty complicated. So we need something to collecting information we need and then present this information in a user-friendly way. So how dalahast collecting information? Dalahast has a C++ class called dalahast as well, working inside each node to collecting node information, server information. Dalahast also provide a default node to collecting error message for all nodes in this server. Second, dalahast has a small system constructed by web frontend as UI and has backend to support the system. So this is the graph of dalahast server, the structure of dalahast server. This section in green line is backend, and this section in red line is front end, and they are all independent and communicate with APIs. Basically, backend is constructed by dalahast class in Haas node and dalahast default nodes and the SQL list database. The purpose of dalahast class in Haas node is collecting information, and this SQL list database contains information like node information, server information, topology information, and error log and others. And the main three dalahast default nodes are error node, control socket, and the control TCP. Error node's job is collecting all error message in this server and store them into dalahast SQL list database. So you can see that all nodes, including users Haas node and the dalahast default nodes, are all connected to the error node. Control socket and the control TCP are almost the same. Their job is receiving requests and passing requests to a specific node. The only difference between them is control socket open a WebSocket port for web frontend, and the control TCP open a normal TCP IP for other dalahast server. These dalahast default nodes are here for interacting with web frontend and collecting information and the others. This is the topology diagram of dalahast latest version right now. These are the default dalahast nodes. This control TCP and control socket are these two, and this error node in private folder is this error node. So you can see that lots of nodes connect to error node to log error. Also, error node has a black ring around. It means that this node is private node, which this is one of dalahast features. You can set node to be private, which cannot be accessed by control TCP and control socket, or you can set node to be public, like of these other nodes. Control TCP and control socket can access them. We can see the lines between control socket and control and the public nodes because we ignore them in UI for clear vision. Now let's run through a real example like this one. Show error log. Web frontend send request to control socket, and control socket pass a request to error log request, and error log request gets some data from share info error log. And finally, error log request return all data to control socket and then the front end. All dalahast information is stored locally, so there's no center server or main server. Every server can be an entrance of topology, but what if we want to see all information among all servers? We don't need to send requests to each server. Let's back to the previous example again. Collecting error log. Here's show error log. Web front end send request to control socket. Control socket pass to worker nodes. Worker nodes get error log from SQL list database. Then you will send TCP/IP request to other servers control TCP for error log data. And after other servers finish their jobs, all error log data will back to the web front end. This graph is better for information storage and stream. So let's run through error log collecting example again. There are 4 servers: server 1, server 2, server 3, and server 4. This green block is called address list. Servers connect to other servers through this address list. It's a little security design. It limits what servers can a server to connect. So server 1 can connect to server 2. Server 2 can connect to server 3. Server 3 can connect to server 4. And there's no server that server 4 can connect. Now, server 1 is the entrance of topology. It receives requests from WebSocket. Then it gets its own data, and it found that it can send requests to server 2. And it sends requests to server 2. Server 2 gets its own data, and server 2 send requests to server 3. Server 3 gets its own data and send requests to server 4. Server 4 gets its own data and found there's no server it can reach. So server 4 return its data to server 3. Server 3 return its data and server 4's data to server 2. Server 2 return server 2, 3, 4's data to server 1. And finally, server 1 return all these 4 servers' data to front end. This is the same graph, but WebSocket now is located at server 2. It means that there's no way to get information in server 1 because server 2, 3, and 4, no one has server 1's address. Although I just may say that every server can be an entrance of topology, but we still need right address list setting. Finally, let's back to the dalahast structure again and the final roundup with some examples. Let's say this is a single machine server, and I want web front end as well. So you can remove control TCP node because this node is designed for other dalahast server to connect. So you can remove this, and you still need to keep control socket for web front end and the error node for collecting error message. Next is this server is one of all servers, and this server doesn't need to be connected from web front end. So you can remove control socket, this node, and you can remove the web front end folder HDNL. But you still need to keep control TCP because this server might be connected by other servers to request data or other things. So which part are constructed by dalahast, which part is my own nodes? Basically, this server is constructed by dalahast and hast nodes. So if this area is dalahast has a HTML folder cover this area, and has a SQL list and admin folder for this area, and a server folder for this area and this area. So if you remove dalahast, then you'll find this server is just pure hast nodes. So the structure of dalahast server basically is constructed by only two things, has node and dalahast. So yeah, that's it. This is the abstraction layer of dalahast. If you have questions, suggestions, you can leave a comment below or open an issue at GitHub page. Thank you.